The broadcast is now starting. All attendees are in listen-only mode.
Hello, and welcome to a webinar hosted by the Cloud Standards Customer Council and the Object Management Group. My name is Tracy Berardi, and I'm the Program Manager of the Cloud Council. Today, we're going to explore the Council's newest white paper called Interoperability and Portability for Cloud Computing, a Guide. The paper is now published on our website at cloud-council.org. You can see the URL here up on the screen. And I'd like to take a moment to introduce John Megan and Mike Edwards of IBM as contributors to the paper and today's expert speakers. John and Mike will define these concepts and will walk us through common scenarios where best practices can be applied. Now we may have time for Q&A at the end of the presentation, and if you'd like to pose a question, please use the questions box at the bottom right of the GoToWebinar toolbar. And with that introduction, I'll turn it over to you, John Megan. Thank you.
Thanks, Tracy. I'd like to mention that in addition to Mike and myself, there were 7 or 8 additional folks who contributed significantly to the paper, and you'll find their names in the acknowledgement section of the document. Mike and I are representing the entire team on this call. And as Tracy mentioned, I certainly do encourage everyone to download and review the paper if you haven't done so already. In the presentation, certainly at the back, there's a link to the paper, direct link, so you can download it directly. Before we jump into the details of the white paper, I'd like to provide a little background on the CSCC itself. So Tracy, if we can move to the next chart.
Do you see that, John?
No, I still see the title chart.
Let me try this again.
That works. Thanks, Tracy.
Okay, great.
The CSCC is a customer advocacy organization that provides guidance and levies requirements on cloud standards bodies. And to that end, the Council develops collateral like best practices and use cases, does standard gaps analysis, etc. And over the past 3.5 years, the Council has grown to over 500 member companies, and the collateral that the CSCC's delivered since its inception is highlighted here on the chart. And at the bottom, we have a preliminary list of projects that the CSCC will be working on next year. And I'd certainly encourage folks who are interested in any of these topics to consider joining the appropriate working group and engaging either as a contributor or a reviewer. You know, the time commitment is minimal, and I can tell you that everyone I've worked with on a project, they've all had a very positive experience. Okay, Tracy, can we move to the next chart?
Yep.
So the remainder of the presentation is going to focus specifically on the Cloud Interoperability and Portability Guide that the CSCC published at the beginning of December. I included on this chart a table of contents for the paper since it provides a good overview of the flow that we're going to use on today's talk. One of the primary motivations for the paper, so the fact that the explosive growth of cloud computing over the past year or two has certainly led to a significant increase in the variety of cloud services being offered. And in many cases, these cloud services are based on proprietary architectures and technologies that sort of increase the risk of vendor lock-in for customers. To help mitigate this risk, customers need to ensure their governance and purchasing policies support a strategy to achieve high levels of interoperability and portability. And as you'll see, a major assertion of the paper is that interoperability and portability both are quickly becoming critical success factors for future adoption of cloud computing. Tracy, we can move to the next chart. So before we dive into details of cloud interoperability and portability, it's important that we're all on the same page in terms of basic definitions. IEEE and ISO define interoperability as the ability for two or more applications to exchange information and, more importantly, be able to mutually use the information that's been exchanged. In the context of cloud computing, interoperability is about successfully using application and service interfaces across public clouds, private clouds, and other diverse systems within the enterprise. Now, different types of interfaces certainly need to be considered, including the functional interfaces of the cloud service itself, security interfaces, admin interfaces, and business interfaces as well. The ideal of interoperability is that all of these interfaces are standardized in some way so that customers can switch to a different service provider with minimal impact. Portability is about the ability to move an entity from one system to another so that it's usable on the target system. And portability is divided into two areas. There's application portability and data portability. From a cloud computing perspective, application portability is focused on the ability to easily transfer and run an application from one cloud service to another cloud service. And really it's the ease of moving the application that's really key. The application may require recompilations or relinking for the target cloud service, but it shouldn't be necessary to make significant changes to the application code as part of the port. And sort of in a similar way, cloud data portability is about the ability to easily transfer data from one cloud service to another cloud service without being required to re-enter that data. The API used to retrieve and import data from the source and target services is a key consideration. In many cases, the API used for the source service may not be the same as the API used for the target service, so some sort of mapping a layer may be required. The second aspect of data portability is the syntax and semantics of the transferred data itself. The syntax of the data should ideally be the same for the source and target services. However, if the syntax doesn't match, it should be possible to map the data using commonly available tools. Now, on the other hand, if the semantics of the transferred data doesn't match, then data portability is likely to be much more difficult and may even be impossible. So Tracy, let's move to the next slide. As you'd expect, there are a number of challenges associated with cloud interoperability and portability. For interoperability, it's not just the functional interfaces of an application or a service that need to be considered. As I just mentioned, security, admin, and business interfaces need to be understood and accounted for as well. There's a very good chance that different providers are going to use different APIs for what are otherwise comparable services. And in general, the level of interoperability decreases as you start to move up the stack. So IaaS has the greatest level of interoperability, and SaaS has the lowest, and PaaS falls somewhere in the middle. Because as you move up the stack, customers have less control over the cloud service interfaces, and these interfaces become more proprietary. There are, in fact, very few standard APIs for SaaS applications, which basically means it's switching from one SaaS app to another with comparable functionalities, typically going to involve a change in interface. Now, there are some practical approaches to handling these interoperability challenges. One possibility is for customers to provide an isolation or a mapping layer between their own applications and the cloud service interfaces, so that the cloud services are not invoked directly. Technologies like enterprise service buses can be used to build these isolation layers. Another possibility is to use the services offered by a cloud broker, who basically takes on the role of mapping a standard interface offered to the customer to a varying set of interfaces offered by different cloud providers. Portability challenges also vary significantly based on the service model. Data portability is really not an issue at the IaaS and PaaS levels, since the customer is in full control of the data syntax and semantics for both of these service models. Application portability is more of an issue, particularly for PaaS, since PaaS platforms can vary widely between different providers. And for SaaS, application portability is not an issue, since there are, by definition, no applications being ported in this model. The customer is basically using the application supported by the SaaS provider. Data portability, however, is a major concern for SaaS cloud services, since the content, the data schemas, and the storage format are under the control of the SaaS provider. And so as a result, customers need to understand how to import and export this data effectively. So in terms of potential solutions, there is some standardization going on at the IaaS and PaaS layers that are sort of easing some of the portability challenges. For IaaS, standards like OVF and standardized interfaces provided by Linux, right, help to sort of simplify application portability. And for PaaS, the increasing adoption of common open source PaaS platforms like Cloud Foundry are certainly helping. And in addition, the emergence of container technologies like Docker sort of allows independent deployment of parts of an application that certainly helps to enhance portability. So Tracy, let's move to the next chart. So this chart illustrates the key elements involved in cloud interoperability and portability that I sort of highlighted on the previous charts. If we look at the left-hand side, from a cloud customer perspective, several roles need to be addressed when creating an interoperability and portability strategy. In addition to end users, developers, administrators and business managers need to be considered as well. Now, from an interoperability perspective, at the sort of the center of the chart, the impact of functional, admin, and business interfaces, along with security considerations, need to be thoroughly assessed. For application portability at the top, it's really the application environment supported by the cloud provider that's going to dictate the ease by which customer apps can be ported. If the app environment supported by the provider is compatible with the customer's on-prem app environment, then portability is going to be significantly less of an issue. For data portability, the ease of moving customer data into and out of the cloud service environment is certainly going to be most important. However, derived data like log files and configuration data needs to be considered as well. And so the next three charts are going to highlight how these elements are impacted differently depending upon the cloud service model that's actually chosen. So Tracy, next chart. So this chart highlights the interoperability and portability considerations for IaaS. The primary considerations for interoperability at the center are highlighted in the shaded area. So admin and business interfaces require the most attention, while functional interfaces should be less of an issue since the customer retains control over these interfaces sort of even after the application services are moved to the cloud. Application portability is somewhat of an issue for IaaS services. One area that's going to need to be addressed is the VM image format supported by the cloud provider. Another question that may arise is whether the machine architectures for the two services are the same. And then at the bottom you'll see it's not highlighted. Data portability, and the reason it's not highlighted on the chart is that data portability is usually not a significant issue for IaaS services since the customer is typically in control of the data format used for these type of services. Next chart, Tracy. So this chart highlights the interoperability and portability considerations for PaaS services. Similar to IaaS, the primary considerations for interoperability at the center, again, are the admin and business interfaces. As I stated earlier, functional interfaces for PaaS are going to be less of an issue since the customer retains control over these interfaces when application services are moved to the cloud. Now, application portability is actually a critical concern for PaaS services. And you'll see that the shaded area over the app environment. And in many cases, the app environment used by the application includes an extensive software stack with many APIs. And the stack typically includes services like web application servers, databases, messaging services, rules engines, etc. And the app code may have dependencies on a particular set of services. So it's vital to know that the set of services available within the cloud provider matches the set of services available within the customer's on-prem environment, and that the APIs for these services are consistent. And then at the bottom, again, similar to IaaS, data portability is usually not a significant issue for PaaS services since the customer, again, is typically in control of the data formats used for these services. Next chart, Tracy. Okay, this chart highlights the interoperability and portability considerations for SaaS services. Okay, unlike IaaS and PaaS, a primary interoperability consideration for SaaS is the functional interfaces of a service. As I mentioned earlier, there are very few standard APIs for SaaS applications, so switching from one SaaS app to another typically requires existing customer applications that are invoking these interfaces to be rewritten to use the new APIs. Then moving to portability, so unlike IaaS and PaaS, application portability is not a concern for SaaS services since the applications aren't being ported in this model. And again, unlike IaaS and PaaS, data portability at the bottom is actually a significant concern for SaaS services since the content, the data schemas, and the storage format are under the control of the cloud provider and may differ from the customer-supported formats. Okay, so with that sort of as background, what I'd like to do now is turn control over to Mike Edwards. Mike is going to take us through a series of scenarios that are documented in the white paper, and for each scenario we'll dig a bit deeper into specific considerations and recommendations. So Mike, over to you.
Thank you very much, John. That's a great overview of the problems of interoperability and portability for cloud computing. So Tracy, if we could move on to slide 10, please. Okay, so we thought in the white paper's great idea to base the core of the recommendations and analysis around a series of common scenarios that many customers are going to face when using cloud services. So here are the 5 that we chose. The first one is a customer simply switches from using cloud service of one provider to an equivalent service of another cloud service provider. That's the whole issue of customer lock-in, one of the big concerns that anyone might have when adopting cloud services. The second scenario is the case where a customer wants to use cloud service but from multiple providers. So you've got at least 2 different providers that you're having to deal with in order to get all the capabilities you need for your business. The third one is quietly increasing in importance as the cloud services market grows, and this is where the customer is going to use multiple cloud services, but where one of the cloud services is being used by another one. So there's a need to link the cloud services together in order to achieve the business goals you're after. So quite an interesting one, that one. The fourth is a very common need to link the customer in-house capabilities, in-house systems with one or more cloud services that you're using. That's a very common thing to do. And the last one, the need to migrate some existing on-premises capabilities that you've got into the cloud services environment. So here then are the 5 basic scenarios that we use to help flesh out the issues and the concerns and possible solutions when dealing with cloud services. So now we'll take some time to look at each of these scenarios in turn. Tracy, if we could move to slide 11, please. Okay, so this is the first scenario. So the before and after picture we have here. Before, you're using cloud service A from provider A, and then you switch and you end up using cloud service B from provider B. But broadly speaking, this is supposedly the same type of service. The considerations here, highlighted in the box on the right there, probably the biggest concern you have is if you had a SaaS service, if Cloud Service A was a SaaS service. And as John explained before, the big problem in the arena of SaaS is that both the APIs that a SaaS application offers and also any user interfaces that has, these are going to be key, and they're not often standardized. So it's a rare thing to find a standard in this area. Just as two applications in PC applications often don't share a huge amount of commonality. It's the same in the software as a service world. For infrastructure service and platform as a service, the biggest issue is when you're moving applications around. Application portability is the big issue you're going to face there. Normally, for IaaS and PaaS services, moving data is not such a big issue because the customer is largely in control of the data formats going to be used. The services provided by the service are relatively low-level storage capabilities. But SaaS also throws up a second problem to the APIs and user interfaces that you have to deal with, and that's data portability. And of course, in the case of a SaaS offering, the cloud service provider normally chooses the way in which customer data is stored inside the service. And they may pick the database or other technology they're going to use, and they'll also dictate the formats. And then the whole issue becomes, okay, if I want to get my data out of service A and put it into service B, what formats can I get out of service A and what's acceptable to service B? So the kind of things that we would recommend in this area then are, first of all, from an IaaS perspective, I think you've really got to have a hard look at the two services and try to ensure that you're able to use standard application packaging formats like OVF. OVF is one of the, it's now ISO standard, in fact, it's available, and it is relatively commonly supported by different IaaS services. You should be wary of IaaS services that don't support common packaging formats of that kind. For PaaS environments, we can't be quite so specific about the things to look for, but for PaaS, you're really looking for an app environment that should be based on open technologies and open APIs as far as possible. There are a number of these open technologies that do exist. John mentioned earlier, Cloud Foundry is one of the approaches, and equally there are database APIs like the Mongo database API, for example, that are commonly accepted by a number of different services and should enable you to port more easily. For SaaS-based offerings, I think the best recommendation we can make at the present time is largely to demand that whichever service you use have well-defined APIs that have a proper description of the APIs they're using, the protocols they're going to use with those APIs, and also the data formats they're going to use for transferring data in and out of the service, and ideally they should be standardized wherever possible. And there are a number of generally available formats for data that are acceptable. You might think of CSV format, for example, for structured databases, but equally maybe use XML or JSON formats, which are often supported, and there are a lot of tools to help you work with those sorts of data formats. Okay, so that's the principal concerns and recommendations when dealing with moving from one provider to another. Let's move on to scenario 2, which is on slide 12, please. So the second scenario we have is where now, instead of switching between providers, you're actually going to use two or more cloud services from different providers at the same time. And here the principal considerations are that your customer systems are now going to have to interact simultaneously with two or more of these cloud services, and the main need is going to be a consistency of the administration, the management, and the business interfaces. It's not necessary for the capabilities of Service A to be the same as Service B. They may be dealing with completely different functional areas, and that's fine, no problem. But what you don't want to have to find is that the administration tools you have to use, the management tools, are completely different. And that would cause some amount of pain for the staff inside the customer to have to deal with that. So you should be looking hard at the admin, the management, the business interfaces, and looking for consistency. And the sort of recommendations we would make in this area is that you should consider using some form of mapping layer where necessary. So off-the-shelf tools that help you do that are enterprise service buses, ESBs that can help you do that, to iron out the differences between what might be provided by provider A and what might be provided by provider B. It may also be wise within the customer business to deliberately choose the tooling you're going to use for business administration management capabilities. Choose tools that have adapters that are capable of dealing with different interfaces for these essential capabilities. And you should also be looking out for the service to support as many common or standard technologies as possible. So a good example of that, which is very heavily used, ID and access management. I'll commonly need to be able to log my users into the service, Cloud Service A and Cloud Service B. What I'd like to have is a common technology for doing that. I should be looking for both services support, example, for third-party identity and access management, so I can use either a cloud-provided ID and access management tool or indeed use my own in-house ID and access management system, and that's often the ideal because you'll probably have all your user IDs already present in an on-premises ID and access management system, and it will be really great if you can get your various cloud services to actually redirect and use your on-premises ID and access management for that capability. The more common or standard technologies of that kind you can find to use with the service, your cloud services, the better. Moving on to slide 13, which is scenario 3. Now this is somewhat of a variation, but becoming more common when you're using multiple services in the cloud. And that is where you have a situation where you are using two services, but one service is used by the other. So an example of this may be you have some business application running in Cloud Service 2, but that's going to provide some analytic data that is going to be provided, say, Cloud Service 1 here, that's going to do analysis of what's happening and provide analytic reports to the customer. So there's a need then to use an API on Cloud Service 2 to get the data that's needed for Cloud Service 1 to perform its analysis work. So the essential considerations here is we've now got some kind of API being exposed by Cloud Service 2, and that's being consumed by Cloud Service 1, and that the interoperability of those two services then along that link through the API, that's the main thing that's going to be of concern. One thing to consider in relation to that interface is that you're often going to need to secure that interface. I don't want anybody getting into your data coming out of Cloud Service 2, so you have to be sure that the right security is in place and that the right credentials, for example, can be used by Cloud Service 1 when it invokes the API in Cloud Service 2. So, things to think about and recommendations we would have for you if you're going to build a system of this kind. You first should ensure that you've got a well-defined and a well-consumable API present on Cloud Service 2. So ideally they're using standard protocols. Even if the API is unique, they should be using, for example, REST HTTP using JSON, or maybe SOAP HTTP, something like that. And it's got a good, well-defined description of what all the operations are. You may consider using an adapter layer in front of cloud service to in front of an API. That's commonly done, for example, with a relatively small PaaS app fronting a SaaS service in Cloud Service 2. And that will be to sort of normalize the interface to make it convenient for Cloud Service 1 to consume the API. That's a common approach today. And then you really have to look carefully at the security technologies, the encryption, the authentication techniques being used between Cloud Service 1 and Cloud Service 2, and you've got to ensure that Cloud Service 2 can indeed be consumed by Cloud Service 1 in the security area as well as in the basics of the API. Okay, moving on then to scenario number 4, which is on slide 14. So a very common requirement is, of course, when you go use a cloud service, that you have a lot of existing stuff on premises which you're going to need to connect up to the new cloud service. And that can consist of functional business applications, but it is also the management, financial management, the administration tools, all those kind of things. So in this diagram we see those separate interfaces, the functional stuff at the top, the administration in the middle, the business interface at the bottom, all those potentially needing to be connected between the in-house applications and systems that you have and the cloud service that you're going to connect to. And you're going to need to be aware of the potential for not only connecting outwards from your in-house applications to the cloud service, but as is shown by the double-headed arrows we have here, there may well be places where you need to connect the other way from the cloud service in to your in-house applications and systems. And that's where problems can start, because it's often not the case that your in-house applications have been exposed in this way to something that's external. So that's one of the first considerations here, is you need to think about having or creating well-defined APIs for any on-premises data or on-premises functionality that are going to be needed by something that's running in the cloud service. The next thing is to think hard about the integration of your in-house admin functionality with the admin capabilities of the cloud service. You may well have had in-house admin stuff for managing your in-house applications. What may not have been done in the past is, again, going out over some internet connection, usually to something external, the cloud service, and managing that. And of course, the admin interfaces offered by the cloud service may themselves be very different from what you were used to using in-house. You need to compare carefully. There may be new security requirements if you're exposing stuff to the cloud service from your in-house applications. You may have not have done that before. There may be a very severe firewall preventing any kind of access of that kind. You're now exposing APIs. Those need to be carefully controlled. And you need to probably put a security solution in place to manage that. The business interfaces at the bottom two may well be very new. It may not have been necessary to have some of the business interfaces that the cloud service will require you to have, but cloud service, you're going to have usage-based pricing. You're going to need to get billing information, invoices and stuff coming out of the cloud service and be able to handle those in your in-house systems. So you need to provide appropriate hookups for those interfaces. And the recommendation we make here is that ideally your on-premise application should be leveraging SOA design principles that will assist in getting your APIs available when you need to expose them. Where you have to connect in-house out to the cloud service, potentially using interfaces that may be novel, that were not used before in-house, then consider something like an ESB to perform interface, protocol, and data transformations, all of which may be necessary in doing these connections. You'll need to address the security issues in the case where a cloud service come back and access on-prem capabilities. So that may need appropriate credentials, encryption, and so on to be put in place to make sure that you don't compromise the security of your on-premises stuff. And look very carefully to see if your in-house systems can in fact deal with the business aspects of cloud services. Cloud services with their charging model may be something completely new for your in-premises systems, and you may need in fact to purchase or use new in-house capabilities to deal with it. Let's finish off with the final scenario then, scenario 5, that's on slide 15. And this is another common occurrence where you want to migrate some stuff that was previously on-premises in your own environment, but now you're going to put it into a cloud service environment provided by some cloud service provider. If this were going to be a SaaS application in the cloud service, then of course you wouldn't be actually porting any code at all. Then in the SaaS environment, the big thing is going from an on-premise app with some set of interfaces that you knew and loved to something completely different probably in the cloud service provider. So it's the API differences, or indeed the user interface differences for that app that you're going to have to worry about. And you're also going to have to worry about taking any on-premises customer data and migrating it into the provider environment where the format may be different and be stored in a different way. For IaaS and PaaS environments where you are migrating actual app code from on-premises into the cloud environment, then you really need to look very carefully at the application environment that the cloud service provider makes available and make sure that is suitable for the app you're proposing to move. It's part of the due diligence you'll have to do. If it isn't 100% matched, maybe that's not a problem. You can actually do tweaks to the application to make it adapt to the cloud service provider's app environment, but you need to take that on board. There will probably be new security requirements. You're now potentially transmitting stuff over the internet between the on-premise environment to the cloud service environment, so you'll need to think about authentication, encryption, such like, to make sure that the data that is transmitted is safe. And last but not least, as we saw for scenario 4, you've got to worry about the compatibility of the administration of business interfaces for the migrated app. How does that compare with the previous on-premise environment that you were dealing with? So for SaaS, you really look hard at the compatibility of the application that's in the cloud service with the on-premises apps that you're using. And that will probably guide the choice of which cloud service provider you decide to go with. For PaaS environments, and really for IaaS, you need to check out the app environment that's being provided by the provider, make sure that it's a good match to the application that you're moving from on-premises to cloud. And finally, check compatibility of your administration business capabilities that you're running in-house. If necessary, you may have to buy new because you didn't have it before, or you need to have additional adapters for those systems to connect to the cloud service and the capabilities that are being provided there. Okay, so all that is reflected in greater detail in the paper itself, and I encourage you to read the paper and understand in depth the sort of considerations and recommendations that are good for those sorts of scenarios, which I think you'll find are common when using cloud services. If we move to slide 16, we have a summary of the sorts of recommendations we make. A smaller set down the bottom for portability. Portability for IaaS, largely a question of using standardized packaging formats like OVF for the applications. For PaaS, look for compatible app environments and common open technologies. Those are the key things to ensuring portability between different cloud services. And for SaaS, insist on standard protocols, standard data formats, open technologies as far as possible. We know that the APIs are likely to vary from one SaaS provider to another, but the more that is standardized, the better. For interoperability, we need to think about SOA principles for on-premises systems that may have to be connected then to cloud services. ESBs or similar mapping technologies are a great idea to provide a buffer between applications on-premises and cloud services, so any variations can be dealt with there. Leverage technologies such as third-party identity and access management, which use standards. There are a lot of good standards in that area available, and that will enable you to share technology across different services and indeed with on-premises systems too, potentially. You need to consider using an API management technology if access is needed from the cloud systems back to on-premises, which is a fairly common requirement. And again, that needs to be done in a controlled, secure way, minimizing risk. You should be looking to insist on the cloud provider providing admin and business APIs using open technologies as far as possible. Standardized security technologies, encryption and so on, you should be looking for those. And where there are APIs that are not standard, as will often be the case for SaaS applications, demand well-defined APIs. You need to look hard at the documentation they provide, make sure it's thoroughly described, anything that they're providing as an API. So those are a summary of recommendations. We then finish off with, on slide 17, a whole set of links to a variety of open technologies. Some of these are standards, such as OVF and CDMI. CDMI is a standard for storage capabilities in the cloud. There are some open standards then. We've got, for example, the ISO Cloud Computing Reference Architecture, which was used to build the pictures for some of the stuff you've seen here in the Interoperability and Portability white paper. And then we have, for example, further down, OAuth 2 is one of the authentication standards that you can use for ID and access management. And then open technologies, which can be useful, for example, in IaaS or PaaS platforms such as Docker and OpenStack. And those are good links to take away. And on slide 16, we would love to have you join the Cloud Standards Customer Council and help us produce future useful white papers talking about cloud computing. There's plenty more to be doing. I have a long list of things that we'd like to do next year. Please come and join us. It's very easy to join. It's free. There's a link here of how to apply, and then you can get involved in the working groups with the link further down at the bottom here. So please come and join us. And then to finish up on slide 19, just to give you some of the idea of the other materials. The next slide, please. That's great. This is a complete list, not a complete list, a big list of the sorts of white papers that Cloud Standards Customer Council has already made available, as well as the Interoperability and Portability Guide, which is at the top there. We have, for example, the Practical Guide, Cloud Computing, and so on down the list. All good stuff for you to read to understand various aspects of cloud computing. And with that, that wraps up the presentation. Slide 20 is just a thank you slide at the end. So with that, I think we should open to questions.
Questions. Thank you, Mike, and thank you, John. Looks like we've got quite a few questions that came in. The first, folks are wondering if the presentation will be available to view. Yes, we'll post it to the Cloud Council website right after the presentation. The URL is cloud-council.org. That is our website. Let's go to this question. What are some of the differences between functional interfaces and business interfaces?
So, Mike, I can take that one. So functional interfaces are associated with the main capabilities offered by the cloud service itself. And the business interfaces involve capabilities relating to the business aspects of the cloud service. So that includes things like subscription information, billing and invoicing, etc. So those are the main differences.
Okay, and let's see. Some IaaS providers allow you to import OVF, but do not allow you to export your machine image as OVF. Let's see. I guess that was kind of partial thought. If you have any.
Yeah, I'll take that one if you like, Mike. Here. Indeed, you have to look carefully at what capabilities are provided by any cloud service. You're right. There are some IaaS and indeed PaaS platforms where you are able to take your application environment and you can put it in, but they don't necessarily allow you to get it back, which then means that at the very least you need to be careful about keeping copies or whatever you put in there. And that could become a problem, of course, if there are any updates being done in the cloud service. So you need to be very wary of a service that won't allow you to get back something that's changed. That's not true of all, of all IaaS services, but it's certainly something to be concerned about. And if you can't get the images back, then clearly you've got to have a system in-house for keeping copies of everything, so that you can, if necessary, move them to a new target service if your business needs went that way.
Great. And does the portability of data for IaaS or PaaS ultimately or largely determined by whether if the application is in-house developed or a commercial enterprise software product? If the latter, if commercial enterprise, I would think all three service models would be similar from a data portability perspective.
Do you want to handle that, John, or shall I?
And I can repeat the question if you'd like.
Oh, I don't know whether John's still with us. You didn't answer then. That's interesting. Okay.
I'm sorry, I was on mute. From a data portability perspective, I think that's less important if it's developed in-house or it's vendor. Mainly because if a customer is using the application, the data formats and syntax, etc., are well known within the enterprise and used internally, right? So regardless of whether that application is developed in-house or developed by an ISV, if it in fact is ported as a cloud service, the data formats are still going to be consistent and certainly not change. Whereas if you're moving from that application to a SaaS or to a different SaaS offering, that's where the issues may come into play, because that SaaS offering is different and the data formats and syntax and semantics of the data supported by that SaaS application may be different. Mike, I don't know if you have anything to add to that.
No, I think you covered it well. I say that SaaS applications are the one to be aware of in the case of data portability. In the other cases, you're typically in charge of what format is being used for the data for IaaS and for PaaS. There may be some instances of PaaS where that's not quite the case, where you may not get a free choice, for example, over which databases get used. But in general, you're in charge of the data as a customer. But SaaS, you're not. It's a different world entirely. That's dictated by whatever the provider decides to use for their structuring of data. So you have to look very carefully in that case.
Great. Thank you. We have a couple minutes left. Let's see. How does security and internal controls play a role in portability and interoperability? So how do security and internal controls play a role?
Mike, you want to take that one?
Yeah, I'm just trying to position it. Clearly, when you start using cloud services, you still have as a customer, a big responsibility for the security of the overall solution. In fact, we have a whole white paper that talks about security for cloud services. It's one of the ones that's being presented. It's in the middle of the page in front of you now. There are a lot of considerations that go into that, and you have to examine the cloud service that you're using carefully to make sure that it will fit in with the security architecture, the security design that you've got for your in-house systems. And part of the linkages that need to be established are the linkages of the administration and management systems being used internally that are controlling the security aspects. So at one level, you've got to make sure that users' identities and passwords and credentials and all kinds of stuff are being managed for the cloud services as much as you'd use it to control access for your internal stuff. It's more of a challenge in the cloud environment because part of the responsibility for actually implementing stuff ends up with the cloud provider. So you're depending on this shared responsibility between your environment and this provider environment, and you've got to be very clear about who's doing what to ensure that you get all risks dealt with appropriately and an appropriate security posture for the services you're using. So I would encourage you to go look at that paper, Security for Cloud Computing, 10 Steps to Ensure Success, which I think describes in quite a lot of detail all the different considerations involved in handling security when you're doing cloud services.
Great, and then just one last question. It's a follow-up from a previous question. How can customers be certain that they retain all copies of their data when moving between cloud providers?
John, do you want to answer that one?
Yeah, that's a good question, and it's actually one of the areas that's covered in the Cloud SLA practical guide that we've got listed here that we're actually updating in the first quarter. That type of assurance is something that needs to be included in the cloud service agreement. And so, as you start planning your move to cloud, you've got to make sure that the service agreement you develop with the cloud service provider covers all of your requirements, and that particular requirement in terms of data is one that should be clearly specified and outlined in the service agreement.
Perfect. And all of these white papers listed here on the screen can be found on our website if you go to cloud-council.org and visit the Resource Hub page. You'll find the link to all of these papers, including the Guide to Cloud Interoperability and Portability. So thank you again for your time today, John and Mike. Invite everyone to become a member of the CSCC and join a working group. And please join us for future events. Thank you, and have a good day.
Thank you.
Thank you.